All right, so we're going to move on with Unit 5, with 5.5, which is going to deal with fertilizers and the environment. It's going to be a little bit different of a lecture video. We're going to talk about some key points, some big things, give you some things to think about in this video. There's another video that accompanies this. It's on your living pacing guide. Be sure you watch that video. And then a couple of the activities you're going to do towards the end of the week is going to ask you to do some independent research on pros and cons of different types of fertilizers. And that will all play into the overall goals of this particular section. So in class, we would ask you, kind of whether you want to call it your bell ringer or your entrance slip or the brain starter, I don't know, whatever you want to call it. Or your do now is what we've been calling it here recently. I would ask you, be prepared to share with the class some important uses for land. Okay, and here's some, I listed some here on this PowerPoint. You can go through big ones there. Farming, of course, is what we're kind of focusing on here. We're going to play into that. Another thing that goes into farming will be land for livestock, recreational purposes of lands for parks and such, wildlife habitat, places to build things on where people live. All those things are important for our important land uses. So there's a study that we would do in class. I'm not going to make you do it virtual, but it's a case study where I would present you with a article that was done recently, a study that was done recently about looking at numbers as far as the population, the human population, how much it's going to grow up until I think it's 2050. We got a graph on here in just a minute. I think it's 2050 or 2100, one of those two. And already in comparing that with the shortage of food that the world is seeing as we speak right now, and what the numbers are showing us is that the human population is only going to continue to grow. And so that gap between the available food supply and the amount of people that need it is going to get larger and larger and larger unless some things start to change as far as how agriculture works. And you can read through this. You can pause it. Feel free to read through it. Long story short, the yields of crops needs to increase significantly very fast. Okay, there's a couple of factors that go into this. One is going to be the amount of fresh water that's available in different parts of the world. Okay, again, if we think about just where we're at, we have access to fresh water, but there's parts of the world that's not as easy to get fresh water as it is here. The second thing is temperatures around the world are increasing, which plays into the amount of product that can be produced. And the one thing we're going to focus on that's not listed on this slide is the lack of new land. Okay. My grandfather used to say, as I was growing up, there's only one commodity that's not being produced anymore, and that's land. The amount of land we have is the amount of land we have. If anything, we're losing land to rising sea levels, and that's playing into everything, not just agriculture, but human living as well. With land running out, so to speak, how can we increase crop yields, the production of crops, with less space? There's a lot of different ways we can go about, and agriculture is going about trying to handle this problem, but still, it's a major problem. And we're going to look at that as far as what land use is, and are fertilizers a suitable option for fixing this problem. So this is just a projection of the human population. So this table is actually from 2012. So it's been, it hadn't been updated here recently, and that's, something that we can look at another time. We can probably go to this link and find a updated graph. But if things continue, you're given 3 different points here based off low, mid, or high, depending on what happens. We're in the middle of a pandemic right now. So maybe, the numbers may be drifting more towards the medium to mid low projection instead of the mid to mid high right now. We'll just have to look at those numbers. But what you do see is that this is what we would call an exponential growth. It is growing steady at a very high rate, and this is not going to change as far as what we're seeing. We would have to have a more severe pandemic or something along these lines than what we're having right now to really cause the human race to stop growing. So the lack of food, which we're already seeing, we already have, it's going to continue to that gap is going to get wider and wider, as we said earlier, unless something is done. So if you look at land use, as far as what our world land is used at for right now, you can see a vast majority of it is going to use for urban and non-urban residential living area, and then forest. And a very small percentage here is used for cropland, um, and not about half of that, or double that rather, is pastures and meadows. So this purple slice really should be alarming, with it being the smallest amount of land use in the world, but yet it provides everything that all the humans need. All right, so a little food for thought. And again, in class, we would have a discussion right here. But I just want you to think about this. So let's just say, for instance, we could calculate it. We're not going to do that. But we could calculate how many more acres of farmland is needed to feed the projected world population. But let's just say if 1 billion acres of extra, on top of what we already have, on top of the 12% that is already being used, if we required another 1 billion acres on top of that, to produce the amount of food that is needed to feed the world's population, where is that land going to come from? Just think about it. Where is it going to come from? I mean, we can't produce new land. So what the land we have is what we have. But yeah, we can repurpose some land, but getting rid of forests, the amount of forests in the world has become very controversial over the last decade. And so no one really wants to do that, nor is it what typically ideal for farming without a lot of investment into making that land right. Now, or you could take some of the residential homes in areas where things are built, infrastructure is built. So then that leads to the question: how much are you willing to sacrifice? Would you be willing to sacrifice? Let's say you were a landowner, okay, and you had multiple shops or buildings or houses or whatever. Would you be willing to sacrifice some of it? You know, say a fourth or an eighth of it to farmland? A lot of people probably wouldn't. So where's this going to come from? Really want you to start thinking about that as we move through this unit. All right, so fertilizers. Everybody said, well, fertilizers can be a solution, and it can be to a degree if it's used right. Fertilizer gets a bad rap. Um, some types of fertilizers over the years that have been produced gets a bad rap, and rightfully so. But as we get more educated with how we make things and use things, we get better with it. So there's always a glass half full, half empty type of view here. So talk about fertilizer application. So fertilizer must be added at the right time. Fertilizer should be applied during the part of the plant's life cycle when the nutrients are needed most. All right, this if fertilizers are applied at the proper time, then a majority of those fertilizers are going to be uptaken or taken up into the plants and not wasted and causing pollution. Fertilizers need to be added at the right place. Fertilizers should be applied in a location where nutrients can be taken up out of the plant's root system. Fertilizer is added at the right rate. Fertilizer should be applied at the rate at which the plant can use the nutrients, not too much, not too little. And all this is a science, and we've learned this, and we're getting better at this. We're getting better at the application, when we put it down, how we put it down, but more importantly, the kind of the behind the scenes look, which we talked about before Christmas break, was soil testing. What's in your soil? What is needed? Okay, you might not need any more nitrogen for this growing season. You might have enough nitrogen in the soil. And if that's the case, then you don't need to put any nitrogen fertilizer down, or so on and so forth. And we've gotten smarter about this, not just as farmers, but as scientists, being able to look at these things and coming up with a formulated plan for a certain area. All right, so two big types of fertilizers, and this is going to play into to your assignment here towards the end of the week. And you can classify them into these two. You have organic fertilizers and commercial fertilizers. Organic fertilizers are typically going to be derived from some type of animal matter, whether it be waste like manure or some other type of animal waste. It's typically kind of the base of it. That would be considered organic. And then you have your commercial fertilizers, which are going to be manufactured chemical mixtures. Again, pros and cons to both. I'm going to leave that up to you to do a little independent research to figure out some pros and cons of both and fill out a chart towards the end of the week. All right, nutrient pollution, kind of the last slide here. So why are excessive amounts of nutrients bad for the environment? And we've talked about this before, just wanted to bring your attention to it again. So as you add or as too much nutrients is added to an area, it's going to cause runoff. And that runoff is eventually going to end up in a body of water. And when these nutrients end up in a body of water, they're going to do what they're meant to do, which is to cause plants to grow faster. And so algae and other plant material in waters, bodies of water, is going to grow faster and more common in those areas, which is going to use up the oxygen in that ecosystem, which will in turn have an effect on the aquatic or the marine life there, et cetera, et cetera, et cetera. You see where we're going here. It's a domino effect. Okay. If pollution occurs and happens and destroys one ecosystem, then that ecosystem being destroyed will have an impact on another ecosystem, so on and so forth. So what is the difference between a point source and a non-point source nutrient pollution? We talked about this. A point source is an identifiable one point where it's coming from. We know where that pollution is coming from. It's easy to identify. A non-point source may be a really large acreage of cropland and it's running off everywhere and it's entering into streams and rivers and creeks and ponds and lakes and whatever, and there's not a typical starting point. It's a little bit harder to track down. Be sure you complete the form that goes with this. If you have any questions, let me know, and we'll continue on tomorrow. Thank you.